Hey guys, welcome to the last day of our notes, day 4 notes. For the acids and bases unit, we are going to talk about the neutralization of an acid and a base. Okay, so an acid and base reaction will produce salt and water when completely neutralized. We kind of talked about this day 1 notes. Okay, they will always produce a salt and a water. Remember that a salt is a compound consisting of an anion from an acid and a cation from your base. It's basically an ionic compound, positive cation, negative anion. Okay, and in general, reactions in which an acid and a base react in an aqueous solution to produce a salt and a water molecule is called a neutralization reaction. Okay, so again, neutralization occurs when you combine an acid and a base. It produces water and salt combined is water. Salt and water. Okay, and again, it's kind of repetitive. Salt is an anion from an acid, and the cation from a base join together to form that salt. And where do we see these processes? Antacids, remember we take them when we have an upset stomach, or we are producing too much acid in our stomach. We take an antacid to kind of increase our pH to settle it. Okay, farmers control the pH of soils, so different plants and different vegetables have a preference on what kind of soil they need. So farmers will add some kind of chemicals to control that pH. And then, of course, the formation of caves. It's not just erosion from the water, but a lot of acids and bases play a role in that too. Okay, so a strong acid and a strong base will produce a neutral solution. So some examples, okay, if we have hydrochloric acid and we combine it with sodium hydroxide, we produce water and a salt. Now, the easiest way to predict how they are going to form new products is by matching them. Okay, so your hydrogen from your acid is going to combine with the hydroxide in your base. And then your 2 in the middle, closest to your plus sign, they are going to combine to form your salt. Okay, so it's the same thing for this one. Your hydrogen from your acid combines with the hydroxide of your base. They're going to produce water. And then potassium and then chlorine are going to combine to form KCl, your salt. Okay, so again, your outer ions are going to combine, and then your inner ions are going to combine. Okay, so let's go ahead and take a look at these examples. If you want to go ahead and predict the products on your own, please go ahead and pause the video. Whenever you are ready, go ahead and push play. Okay, so if we have hydrochloric acid and lithium hydroxide. Okay, hopefully you're practicing your naming acids and bases while you do this. Okay, it should produce, one of the products we always produce is water. And then we also produce, the inner ions are going to combine and form lithium chloride. Okay, now it doesn't really matter which way you write this. You can write it H2O or HOH. It means the same thing. Okay, now for the next one, we have nitric acid and we have cesium hydroxide. So again, hydrogen is going to pair up with hydroxide to form water, and then our other product is going to be cesium nitrate. Okay, cesium nitrate and water. And then lastly, we have hydrobromic acid, and it's going to combine with potassium hydroxide. Hydrogen is going to combine with hydroxide to produce water, and then potassium is going to combine with each other and form potassium bromide. Okay, hopefully you got all 3 of them correct. All right, so titrations. Titration is the process of adding a known amount of solution of known concentration to determine the concentration of another solution. So basically, if you don't know the concentration of one solution, you can figure it out by performing a neutralization reaction or a titration with a standard solution. Now, a standard solution is one of known concentration. You know the concentration of this solution. Okay, now steps in performing a titration or a neutralization. Okay, you first have to measure the volume of an acid solution of an unknown concentration, and you're going to put that in a flask. Your acid always goes in a flask. Okay, after you've placed your acid into a flask, you are going to put several drops of an indicator into that solution. Okay, the reason why you do want an indicator in your solution is because most of the time these solutions are colorless. So if they're colorless, you're never going to figure out when you've reached that neutralization point if they're colorless. Okay, if everything looks like water, then you're not going to know when it's neutral. Okay, so after you've added your indicator, you are going to measure volumes of a base with a known concentration in your burette, and you are going to mix it into your acid that's in the flask until it barely changes colors. Okay, and then of course in class you guys watched a video over this. So if you need to watch that video, I'll go ahead and put the link down below so you can watch it. All right, so endpoint is the point at which your indicator changes colors. So once you have reached the endpoint, you can perform your calculations to find the unknown solution. And really your indicator, the color that you're looking for is a very light, pale pink color if you're using phenolphthalein as your indicator. Now once your indicator turns a very bright pink or magenta color, you're no longer neutral. You are strictly a base now. Okay, so again, if you need to watch the video, these are the links right here. Okay, now let's go ahead and take a look at an example problem. Okay, so a 25 milliliter solution of sulfuric acid is completely neutralized by 18 milliliters of a 1.0 molar solution of sodium hydroxide. So what is the concentration of your sulfuric acid solution? Okay, so the very first step you need to know, or you need to do, is to balance your equation. Okay, without a balanced equation, you are going to mess up the whole problem. So number one rule, have a balanced equation first. Okay, so go ahead and pause the video. Try to figure out what your coefficients are for the balanced equation, and as soon as you're ready, go ahead and push play. Okay, so your coefficients for this equation should be 1, 2, 1, 2. Okay, that should be your coefficients. Again, it's 1, 2, 1, 2. 1 mole of sulfuric acid plus 2 moles of sodium hydroxide produces 1 mole of sodium sulfate and 2 moles of water. Okay, so now that you have a balanced equation, you are going to use this formula right here to solve for your unknown. And basically what it is, it's the molarity of your acid times the volume of your acid divided by the number of moles of your acid. And the number of moles is your coefficient. So what is the coefficient of your acid? That's what Na is. And you're going to set that equal to the molarity of your base times the volume of your base divided by the number of moles of your base. So what's the coefficient of your base? Okay, so this is what I was telling you, that if you don't have a balanced equation, you're gonna get this wrong. Okay, so for this side, you have a 1, so it doesn't really matter, but the fact that your coefficient for your base here is a 2, that's when you're gonna see some problems. Okay, and then another thing, your volume must be in liters because molarity is measured moles per liter, and you always want to keep your units consistent. Okay, so again, our formula was the molarity of our acid times the volume of our acid divided by the number of moles of our acid equal, oops, not ready for that yet, equal to the molarity of your base times the volume of your base divided by the number of moles of your base. So if you plug everything that you were given from the problem and you plug it into this formula, this is what you should have got. Okay, so the molarity of our acid is our unknown. We don't know it. That's what we're trying to solve. We were told that we have 25 milliliters of our acid. Okay, and our coefficient for our acid is 1 mole. Okay, we also have the molarity of our base, which was 1, and the volume of our base, which is 18 milliliters, and then our coefficient for our base is 2 moles. Okay, so if you do all that math, the molarity that you should have got is 0.36 molar. Now, some of you might be wondering, well, how did you get that? How did you solve for your unknown? Basically, you would cross multiply. Okay, so just like in algebra, you would cross multiply, and then how would you get your unknown by itself? Okay, so if you need help, just let me know. I'll spend a few minutes with you in class to kind of help you brush up on your Algebra 1. Okay, so just let me know if you have any questions about this example right here. All right, some more examples. So how many moles of HCl are needed to neutralize 6 moles of KOH? Okay, so first ask what is the mole ratio and then set it up as a proportion. So since we are given 6 moles of potassium hydroxide and it's asking for how many moles of hydrochloric acid are needed, well, if we have a balanced equation, our balanced equation is telling us that our mole to mole ratio is we need 1 mole of hydrochloric acid for every 1 mole of potassium hydroxide. So if we have a 1-to-1 ratio, then that means we need 6 moles of hydrochloric acid as well to neutralize 6 moles of KOH. Okay, so example number 2, if we have sulfuric acid, and we combine that with 2 moles of sodium hydroxide, it produces 1 mole of sodium sulfate and 2 moles of water. Well, 1 mole of sulfuric acid is needed to neutralize how many moles of sodium hydroxide? Well, that coefficient is 2. So we need 2 moles of sodium hydroxide. Okay, and then how many moles of NaOH are needed to neutralize 4 moles of H2SO4? Well, if our ratio is 1 mole of sulfuric acid to 2 moles of sodium hydroxide, well, if we need 4 moles of sulfuric acid, then we need 8 moles of sodium hydroxide. It's a 1-to-2 ratio, so that would be a 4-to-8 ratio right there. Okay, and this actually concludes our notes for today for neutralization reactions and how to calculate titrations. If you guys have any questions, feel free to comment or ask me in class. Okay, y'all have a good one.